Hello friends, welcome back my YouTube channel MS Maths. In this particular video, we are going to discuss about important questions and solution for the partial differential equation by using Laplace transform. If you want to know about the concept step by step, what is the theory of the partial differential equation by Laplace transform, you can see our previous video. We have discussed totally in our previous videos. Now in this video, we are going to discuss only and only the important questions and what will be the solution for that, and by step we will discuss. Okay, now continue. So first of all, we are going to discuss about a question that is del y over del x minus del y over del t is equals to 1 minus e to the power minus t. So basically, first of all, first step is that solve any OD ordinary differential equation or partial differential equation. First of all, we have to take Laplace both side. So we have a partial differential equation and I am taking this is the equation number 1. Then whenever we start the solution, first step will be taking Laplace transform both side. Okay, taking Laplace transform both side in the equation number 1. So basically in equation number 1, we are going to discuss Laplace transform. So Laplace transform of del y over del x. Okay, and the Laplace transform of del y over del t and Laplace transform of 1 minus e to the power minus t. So this is these are the standard term, and the Laplace transform we have proved about this. The Laplace transform, this is nothing but y bar over dx, dy bar over dx. It means let Laplace of y is nothing but y bar. Okay, minus the Laplace of this is nothing but s y bar xs, the function of xs. Because of that, this is nothing but a function of x and t, and we are going to Laplace, taking Laplace with respect to t. So basically this is nothing but y bar s, t will convert into parameter of Laplace, that is nothing but s, minus y x comma 0. Okay, at t is equals to 0. And now the Laplace transform of 1 is nothing but 1 upon s, and this is nothing but 1 upon s plus 1, because Laplace transform of e power x is equals to 1 upon s plus a, and a is nothing but minus 1. A minus 1, it is a minus 1, then a is nothing but minus 1, so it will be s plus a. Okay, now here you will get OD by applying the initial value condition. We have this initial value condition, this is nothing but x, so dy bar over dx minus sy bar x comma s, this will be plus 1 upon s minus 1 upon s plus 1 by IVP. We have IVP, this is IVP. Now it will be dy bar over dx minus, it is s y bar x comma s, or I can write this is nothing but y bar simply. Okay, is equals to 1 upon s minus 1 upon s plus 1 minus x. Now you can see this is nothing but a linear differential equation, first order, first degree. Okay, so what will be the solution? We will calculate the integrating factor. It is nothing but e to the power p dx, and p is nothing but minus s, so e to the power minus sx. Okay, now the solution of this differential equation is y into integrating factor is equals to integration of q. Q is nothing but the right hand side. Okay, this will be the qx into integrating factor dx plus any constant c. Okay, now we are going to discuss the solution of this is nothing but y. Y means y bar. Here y is nothing but y bar. Okay, so remember this thing. This is the Laplace of y bar, and integrating factor, it is nothing but e to the power minus sx, and integration of the right hand side, this is nothing but 1 upon s minus 1 upon s plus 1. Or I can write this is as okay, now I will solve here. Okay, minus x is here, and integrating factor e to the power minus x dx plus c. Okay, now solve this differential and integration sx equals to, now I can write this is nothing but 1 upon s into s plus 1. Okay, minus of x e to the power minus x dx plus c. Now integrate this term, it is very easy. So 1 upon s into s plus 1 e to the power minus sx dx, on multiplying this both side here and here. and it will be the minus of x e to the power minus x dx plus c, and y bar e to the power minus x, it is constant, 1 upon s plus 1, and the integration of this is nothing but e to the power minus x over s. Okay, and the integration of this is nothing but x, this is first, this is second, by using Euler formula, x into e to the power minus xx upon s, and this will be the minus, and the derivative of this term is this, and again sx over minus s dx plus c, and again solving this to the power minus x, 1 upon, this is nothing but s square minus s plus 1 into e to the power minus sx minus of x e to the power, firstly solve this bracket completely, so sx minus, now here this minus and this minus will plus, but on integration it will be again minus s over minus s square, okay, plus c, it will be the constant. Now here what can we do here? Okay, by taking e power s minus x common, so it will cancel, and also here is e to the power minus, or you can write e to the power minus x over e to the power minus x, multiplying, dividing, and got common, and it will cancel. And the next thing is minus 1 upon s square s plus 1, this will be the minus plus 1 x over s, and this will plus 1 upon s square, and plus c e to the power, ये ऊपर आएगा, so e to the power minus of sx. Okay, now here this will be y bar is equals to, I can solve this term both, so I am taking the common, I am taking the LCM basically, so it is nothing but s plus 1 minus 1 upon s square s plus 1, so plus x upon s plus c to the power minus sx. Now like 1s cancel, so y bar is nothing but 1 upon s plus 1 plus x upon s, which is nothing but s c to the power minus xx. Now here is a constant, so how can we solve the constant here? Like we have the OD, we have the PDE in which the x belongs to 0 to 1. If x tending to infinite, and y bar should be finite. Okay, for this condition y is bounded, one thing is that y is bounded also, y is bounded here, so to obey this condition c have to 0. Okay, to obey the condition c will have to 0, that is c equals to 0. It means y bar is nothing but 1 upon s into s plus 1 plus 1 s upon x upon s, and I can write on partial differentiating this term, or like this will be the, we have write this term as this, and I can write this term as like 1 upon s minus 1 upon s plus 1 plus x upon, or you can like a partial fraction of this term, you will get this on taking, now on taking Laplace inverse, taking Laplace inverse, you will get y is equals to the Laplace inverse of 1 by s is nothing but 1, and it will be the e to the power minus of t. Okay, it is the function of t, e to the power minus t, and plus x. So this will be the required solution for this partial differential equation by using the Laplace transform. Now move to the another question. Now here is a second question of the partial differential equation. We have a partial differential equation, del y over del t is equals to 2 del 2y over del x square. Okay, we have a substitution, the Laplace inverse of del y over del t we have discussed in our previous question, like that is nothing but s y bar x comma s, okay, and minus y x comma 0, and also if we have del y over del x, then we will put del y bar over del x, or del 2y bar over del x, del 2y over del x square, it is nothing but d2y over dx square. Okay, this is the substitution, and now we will substitute here. So the solution is starting from taking Laplace transform both side. So taking Laplace transform both side of the equation number 1. So it is nothing but s y bar x comma s minus y x comma 0. Okay, it is the substitution for this, and this is equal to 2 of d2 y bar over dx square. Let us consider the Laplace of y is nothing but y bar. Okay, now here we can put the value of this is nothing but 10. So s y bar sx minus, so it is 10 sine 4 pi x is equals to 2 d2 y bar over dx square. Here we have the value of y bar sx. What is the value for this? We can calculate by using x comma 0. Okay, no problem. Okay, this is okay. Now it is like I can write del 2 y bar over del x square minus of s y bar x. I can write only y bar. Okay, only y bar, and is equals to or plus 10 sine 4 pi x. Now on dividing by 2 is equals to 0. On dividing by 2, del 2 y bar over del x square minus s by 2 y bar is equals to minus 5 sine. I am sending in the right hand side 4 pi x. Okay. Now it is a second order linear differential equation with constant coefficient. So how can we solve the solution for this differential equation? By it is nothing but if I am considering d2 by dx square is nothing but d2, so I can also write it is nothing but d2 minus s by 2 y bar is equals to 5 sine 4 pi x. Now the auxiliary equation for this is nothing but m square minus s by 2 is equals to 0. Solution for differential equation is nothing but y is equals to complementary function plus particular integral. We are going to calculate the complementary function by using the auxiliary equation, and the root of this differential equation is nothing but this one, and we like when we have the roots, two roots, then like which are distinct also, then the solution of this differential equation is nothing but y is equals to, or it is nothing but cf, complementary function. It is a c1 e to the power root of s by 2x and plus c2 e to the power root of s by 2x, and it is minus. Okay, now we have to calculate the particular value by using this homogeneous non-homogeneous function, or particular integral is nothing but minus 5 sine x 4 pi x over the function fd. It is nothing but d square minus s by 2. Okay, now a is like this, like the value of it is nothing but put d square minus of a square, and a is nothing but 4 pi. It means pi is equals to minus 5 sine 4 pi x over the power 2 or square of 4 pi. Okay, 2 4 pi. Okay, yeah, it is okay. So 4 pi 16, I can write 16 pi square minus s upon 2, or I can write like this, taking LCM, 10 sine 4 pi x over minus 36, and minus minus got cancelled, or we can write it is plus 32 pi square s. So this will be the PF. So the general solution is nothing but y bar is equals to, okay, y bar, we are working on y bar. So y bar is equals to CF. It means C1 e to the power root of s by 2x plus C2 e to the power minus root of s by 2x plus 10 sine 4 pi x over 32 pi square minus s. Or not minus s, this will be the plus s. Okay, by taking minus common from here, so it will be the minus 2s or plus 2s by dividing. Okay, let me check, d square minus s square. Okay, d square minus s by, okay, correct. Now we have IVPs. like y0t is equals to 0. It means the taking Laplace both side for this IVP also. So it is nothing but 0 and t will convert into s is equals to 0. It means the value of x equals to 0, y equals to 0. The value of x equals to 0, y equals to 0. Then okay, this is not equal. Okay, this is not also equal. Sorry for that. So one IVP is this and second IVP is also this 5t, and I can write this is nothing but 5 or s. It means x equals to 5 and y equals to 0. Y bar is equals to 0. Now on putting the IVPs here, it is 0, 0, it is 1. You will get this answer. This will be the this will be the equal to 0. It means this equals to 0 means tan sine 4 pi x equals to 0. Whenever it will equal, like the whole term will equal, 0. Okay, sine pi 0, sine pi is 0, x is nothing but 0, then it is 0, sine pi it is also 0, so it whole term will be 0. Or if I am going to using this, it will be the 5 and it will be the 5, and also here c1 plus c2 equals to 0. Whenever we will put this value, you can see here this term will e power 0 is 1. Okay, e power 0 minus 0 is also 1. So this will 0 by using this IVP. By using, or I can write here c1 plus c2 is equals to 0, and here is nothing but x, and we will get the value c1 plus c2 equals to 0, and by this c1 equals to minus c2. On putting this IVP like this, if I am putting y bar equals to, or it is 0 for this IVP, 5 s, okay, it is 5, okay, it is 5, it is s equals to 0. Okay, 0 c1, see here, it is nothing but e to the power root of s by 2 5 plus c2 e to the power root of s by 2 minus 5, or c2 is nothing but minus of c2, and this term will be 0. On put, oh, not, this term will not equal 0. Yeah, equals 0. Because of that, when x equals to 0, yeah, I can write a tan sine 20 pi over 32 pi square plus s. 20 pi, sine pi is always 0, so it will always 0. It means it becomes 0. Or I can take common here, c1 is equals to minus c2, so c1 is equals to c1 e to the power root of s by 2 into 5, or minus e to the power minus s by 2 5 is equals to 0. This term is constant, it means c1 equals to 0. Whenever c1 equals to 0, it is equals to minus c2, it means c2 equals to 0. So the solution for this term will equals to 0, this term will equals to 0. So y bar is only equals to tan sine 4 pi x over 32 pi square plus s. Okay, and now taking the Laplace inverse of this term, taking the Laplace inverse or inverse Laplace transform, I can write ILT, inverse Laplace transform. It means it will be the y bar equals to tan sine 4 pi x, it will be the constant. We have this term, like I can write s plus 32 pi square. It means 1 upon s minus a, like, and it is nothing but e to the power minus at. Okay, e to the power minus at. The Laplace transform of this is e to the power minus at. It means it is e to the power minus 32 pi square t. 32 pi square t. So this will be the required solution for this differential equation. We can easily calculate that the working process of the partial differential equation is only and only for here. Like this one step is only related to the partial differential equation. The total whole working system is, whole solution is depending on only and only ODE, ordinary differential equation. If you know about the concept of second order differential equation, like the solution of differential equation, you can easily solve the partial differential equation by using the Laplace transform. So thanks for watching my video. Keep watching Maths, and please subscribe the channel, like the video, share the video, and support us. Thank you. Bye bye.